Now, before going into the core of the principle of working of laser, let us talk about the spontaneous emission. Now, if I have the atoms in which I have E1 and E2. Now, the atoms that are in the excited state or in higher energy level, they stay in that level for a very short span of time. And the average time, they will stay in higher energy states is of the order of 10 to the power of minus 8 seconds. And then after that, the atom goes back to the ground state by automatically emitting the radiation in the form of photons. And we understand that the energy of that photon happens to be E2 minus E1. And the point here is that the atoms in the excited state, when they come back to the ground state, they emit radiations in a very short span of time on an average of 10 to the power of minus 18 seconds. And this kind of emission that we have, this kind of emission is called a spontaneous emission. And I would like to say that a spontaneous emission is a process by which an atom moves to its ground state from the higher energy state of its own by emitting photons, by emitting radiation. And the energy of the photon that is emitted during this process, during this spontaneous emission, is given by this equation. And one point to be noted here is that the spontaneous emission is a source of ordinary light. And for example, the light emitted by the sun, if I take an example of sun, stars, electric bulb, the light that is emitted by these sources is due to the spontaneous emission and this light emitted by the ordinary source of light that we have, this light is incoherent. Okay, so what we have is we have a source of light and we achieve the light, and when the atoms go back to their ground state, they emit light of all possible frequencies and wavelengths, and this light is the incoherent light. Okay, so this is what's called as spontaneous emission. So the emission of radiation from sun, stars, and electric bulbs, they are the examples of spontaneous emission. Now, going to another dimension here is stimulated emission. And this emission was basically, it was proposed by Einstein in 1917. And what he proposed that in addition to the spontaneous emission that we have discussed, there could be another type of emission, and that emission is known as stimulated emission. Now, what we have is we have two states of atoms. Now, suppose there is an excited atom. The atom is in excited state, which is illuminated by a photon. So this is excited atom. It's illuminated by a photon of, say, energy h nu, exactly equal to. Now, the energy that's given is exactly equal to the energy difference between the energy of excited level and the energy of the ground level. So the energy that we are supplying to this atom to go into the excited state is same, or is the difference of the energy of the excited level and the energy of the ground level of the atom. Now, the incident photon stimulate the atom. What it does, what should I say, it exerts a kind of force on the atom. It's a force on an atom to move from excited state to the ground state. So the atom is already in the excited state, and we are supplying an energy of energy. We are supplying an external energy to this excited state. And when this event takes place, what happens is a photon of the same wavelength as that of the photon that we have imposed on this system, as that of the incident photon is emitted. So you are having this, the energy of the photon that's emitted by this atom, which was already in excited state. When we supplied an energy of h nu to this, we forced the transition from excited state to the ground state. And what happens is that we have the photon coming out of it. And these two photons are exactly in phase. The photon that was supplied to the system, which was already in excited state, is same as that of the photon that is being emitted by this atom while going to the ground state from excited state. And this process of emission of photon is called as stimulated emission of, we call this kind of emission of radiation as stimulated emission. Thus, if I have to stipulate it in simple words, it is the process by which the incident photon that we have, it stimulates an atom in higher energy state. So we have already an atom in higher energy state to jump to the ground state. To jump to the ground state by emitting a photon having the same energy and phase as that of the incident photon. And this kind of phenomenon is called as stimulated emission, emission of energy. Okay, so this stimulated emission, basically, it leads to the emission of photons, which have the same energy and phase as that of the incident photon. So the radiation emitted by the stimulated emission, they are exactly coherent, because the emitted photon has the same initial phase as that of the initial photon, and has the same wavelength, has the same frequency as that of the initial photon. So what we have here is the coherent emission of radiation. And in this stimulated emission, an incident photon, basically what it causes the emission of one identical photon. Two incident photons will cause the emission of two identical photons. Three photons will lead to the emission of three identical photons. So the stimulated emission amplifies the incident light. Right? So this stimulated emission is possible if the atoms of the substance are already in the excited state. You cannot have this stimulated emission when you have the atoms in the ground state and you will take them to the excited state first, and then you will cause some radiation to fall on it. What is important is you have to cause your radiation to fall on it when your atoms are already in some excited state. Now, so we should say that under ordinary conditions, the number of excited atoms in the system is less than that of number of atoms in the ground state. So that could be the reasons that can be prevailed here. So this is what is called as, this is how we can understand that we have a stimulated emission. And the stimulated emission is that you have the output radiation in phase with the input radiation. So all the photons that are coming out of the system are in same phase with respect to the photons that are falling on the system.